Okay, in this video lesson, we'll be looking at graphing transformations of sine and cosine. Alrighty, up to this point, we've looked at the components of the graph, like the midline, the amplitude, the maximum, min, and period. Also, we followed with the different transformations, like vertical shift, the horizontal shift, the vertical stretch and compression, also the reflection about the x-axis, and the horizontal stretch and compression. The last thing was the phase shift. So what we want to do now is consider the graphs, actually graphing these different transformations. We already know that y to sine of x looks like this, and y equals cosine x looks like this. So in order to graph it, we're going to look at, okay, how many points do I actually need to know in order to graph it? So if I just focus in on the primary cycle, so this first cycle from 0 pi to 2 pi, it looks like I need a total of 5 points in order to graph a complete cycle. If I looked at cosine, the same thing, the primary cycle, the main one, I would also need 5 points. So with that being said, let's look at all the different situations you would ever see for both sine and cosine, meaning this. If we had y equals sine x, and again, I'm only focusing on the primary cycle. If a was positive, we going from the picture would look something to this effect. If y equals negative sine x, everything is reflected over the y-axis. So we end up with this picture or this graph. Then we look into cosine. It's cosine with the a being positive. We end up with this graph. And if the a was negative, it's reflected over the x-axis. So these are the four primary graphs you would ever see for sine and cosine. When we look at the first one, the sequence of points go from the mid, the max, the mid, the min, the mid, meaning sine starts at the midline, and if the a was positive, we're going up to the max. Whereas if the a was negative, again, we're starting at the midline, but now it goes down to the min, mid, max, then mid. So we have the sequence of 5 points. Similarly with cosine, if a was positive, we're starting at the maximum, going down to the mid, to the min, to the midline, to the maximum. But if the a was negative, again, the graph is reflected. So what was up is now down. So in this case, we're starting at the minimum to the mid, the max, mid, and min. So the sequence of 5 points will be critical when we look at actually coming up with these 5 coordinates. So in order to graph, this is the sheet or the graph paper that I propose using. What I meant by this is that the middle line here, we will always use this middle line to graph the midline. At the very top, we'll always graph the maximum. Here, we'll always graph the minimum. We'll focus primarily on the primary cycle. So from this point would be the left bound, and over here would be the right boundary. So the entire graph, the entire cycle, those whole 5 points will be drawn within this region. So those are 2 points would go on each of these lines, so we'd need 3 more. So if I cut it right in half, there's our third point. Cut this right in half, that would have been the fourth. Cut this right in half is our fifth. So here is where we would put our 5 different points in order to graph either sine or cosine. I could replicate this going backwards, and then I would have enough places to graph points to show 2 complete cycles. So this is the graph paper that I propose using. So let's look at an actual example of actually graphing this. So we're going to find the normal things we normally would. The midline, the amplitude, the max, min, period, phase shift. The theta and the coordinates we'll be looking at shortly. That's the new stuff. So let's go with the old. The midline, y equals 5. My suggestion is as soon as you find information, begin to graph it. So if the graph says this is always the midline we just found is 5. So let's keep going. Amplitude is 4. which means then my maximum is 9 and my minimum is eventually going to be 1. And as I'm finding it, I will actually graph it. Because the maximum was 9, the top line is always the maximum, 9. The bottom line is always the minimum. So now, before I go into period and phase shift, we actually can begin to identify the coordinates. The deal is we're going to have 5 coordinates. And because, if I look at the original equation, because the 4 is positive, the A is positive, that means our first point will be on the mid, then up to the max, the mid, the min, and the mid again. So we're using what we saw earlier, the sequence of these 5 points. So if I show where those 5 points are going to be graphed, I can actually graph it without having any numbers because I know the locations. The midline, the max, the mid, the min, and the midline. So with this being said, we now have values we could substitute into our coordinates, meaning this. We have the vertical coordinates. The midline is 5. So 5 is my second coordinate, my y coordinate. Next point, maximum is 9. Next point, mid is 5. The min is 1. And the mid is back to 5. So in creating our coordinates, the midline, the max, and the min are actually the values for our y coordinates or our vertical coordinates. So now we can continue where we left off. Period. Period is going to be 2 pi over 3. That's 2 pi over 3. Phase shift, negative c divided by b, which would eventually give us negative pi over 6, which means the phase shift is left pi over 6. Now we can begin to bring our attention to theta. Theta will represent the values horizontally. To find these values, we put our entire focus on what's inside the parentheses. These are the values that will assist us. There is a generic equation or format we will take. The generic format will be left bound is less than or equal to whatever's inside the parentheses, less than or equal to right bound. Specifically, because this is sine, the original left bound, it originally started at 0 pi, and it originally ended at 2 pi. And when we substitute what's inside the parentheses, this is the inequality we get. And we're trying to find theta, so we're going to use inverse operation to determine theta. So to get theta by itself, I'm first going to subtract pi over 2 on all 3 sides. Arithmetic leaves me with negative pi over 2 is less than or equal to 3 theta, less than or equal to 3 pi over 2. To get theta by itself, let's divide everything by 3. The arithmetic gives us negative pi over 6 is less than or equal to theta, less than or equal to pi over 2. What this is saying is that our new left bound will be negative pi over 6, and our new right bound will be pi over 2. So these are 2 of the 5 thetas. To find the other 3 is as simple as averaging. The average of these 2 points will give me this number. So let me quickly demonstrate that on the calculator. We got negative 1/6 and 1/2. Negative 1/6 and 1/2. So the average, we simply add it up. Negative 1/6 plus 1/2. There we go. So the average, we add and then divide by 2. There's our middle number, pi over 6. Our average, pi over 6. To find this point, we'll average again. Well, the average of negative pi over 6 and positive pi over 6 is 0. Then we average one more time. The average between those two numbers is pi over 3. So now we have our 5 thetas, negative pi over 6, etc. Now we can complete the coordinates. Well, the midline right here is at negative pi over 6. The next maximum is at 0 pi. The next mid is at pi over 6. The min is at pi over 3. And the mid back is pi over 2. So we have all the 5 coordinates. We could fill in the backspace and get our other 4 points, and we have enough now to actually graph our picture. Now I will admit it doesn't show the stretching and the shifting, but what's most important in math is these values. This gives us exactly where things are supposed to end up. I can demonstrate on the graphing calculator to illustrate the differences. So here's our original sine and the 2 cycles from negative 2 pi to positive 2 pi. There's our function. So when I turn it on, I can see there's the stretching. So our midline was at 5. There's 5. So it did shift up 5. Our amplitude was 4. There's our max of 9 and our min of 1. And here we can begin to see how the phase shift comes into play. So we were here at 0. If I put my 5 points, we can see these were the 5 points we plotted. And you can see that this one did move to the left. Looks like about pi over 6. Oh, exactly, pi over 6. So from here you can see the actual transformations that occur. But what's most important in math is not so much the picture than it is the actual values that got you there. In the next video, I'm actually going to do 2 more examples. So from here, this begins to set the tone.